Hello, everyone. In this chapter, I will give you a brief introduction on operating system. In particular, we will talk about what operating systems do. Then we will talk about the computer system, organization, architecture, structure, and operating system operations. And then we will talk about the management of different important components of operating system. Then we will talk about protection and security. So after that, we will talk about kernel data structures and computing environments. So at last, we will briefly talk about open source operating systems. First thing first. So what is an operating system? And some people said that the operating system is just like a government, so where it can provide services to build an environment so that the normal people can do useful things there. And operating system actually is quite similar. It provides a service to build an environment so that people can use software through hardware to do some tasks. So basically, the concept of operating system is a program that acts as an intermediary between a user of a computer and the computer hardware. So operating system has several goals as we list here. The first one, to execute user programs and make solving user problems easier, and also make the computer system convenient to use. Of course, operating system is the one to control and manage the computer hardware. So surely we want to use the computer hardware in an efficient manner. In general, the computer system can be divided into four components. So on the bottom is the computer hardware. Above that is the operating system. The operating system directly control and manage the computer hardware to provide services to build an environment for the application programs to run. So surely above the operating system is application programs. I bet all of you guys can name numbers of applications. For example, the PowerPoint, which I'm using right now to present the lecture, and the web browser, PC games, etc. So there are huge numbers of a variety of application programs. For most of the situations, those application programs cannot execute on their own. So that means they has to be used by users. One thing I would like to mention is that the user could be people or other things. So for example, the user could be a machine or computers. So you may heard about the client-server architecture. So for example, you may use a web browser on your smartphone or computer to download some files from a web server. So in that situation, the smartphone or the computer can be treated as a users too, right? Because they request the service from other machines or computers. So therefore, the users may not be people only. The user could be machines and the computers as well. Next, let's see what the operating system can do. So basically, it depends on the point of view. So from user's view, as a user, we hope the computer can be used very conveniently, right? And the convenience means that, for example, when we want to open a software, so we hope only one click or double click, then we can launch the software. We don't want to do a lot of actions to achieve that. For example, do a numbers of clicks or some tappings just for opening a file. So we hope the operating system can provide a better design, ease of use. And also we hope the operating system can provide us a good performance. So I mean the software can be run very fast and responsible. So for example, when you play a PC game, so you hope the game can run very fluent without any glitch. And also you don't want your characters just stuck on the screen, right? So if these problems happen very often, I don't think you want to play the game anymore. So this is for the single user. And sometimes the system may serve multiple users at the same time. So we call this kind of a system as a shared systems. So for example, the Turing machine. So from users' will, each user may feel that they are the only user who use the system. So we don't want the system become slow and slow as the number of users get increased. The system has to make everyone feel happy. And also, the operating system may work on mobile devices. So for example, the operating system on the smartphones, on tablet, or on some other mobile devices. So for this kind of operating system, beside the convenience, ease of use, and good performance, we may also concern the battery lifetime because the mobile device cannot be charged all the time. So for most of the time, we may use the battery to support the devices. Therefore, the designers needed to take care of the trade-off between the performance and the battery life of the device. So sometimes the designer needs to slow down the software performance a little bit for better battery lifetime. So for example, there are two phones. So one is super fast, more than you need, but the battery can only last for 1 hour. The other one is a little bit slower, but still acceptable. So it can last for a day. Surely, most people may choose the second one, right? On the other hand, from the system view, so you may not care about these aspects before you take this course. So since you guys take this course, so you may need to consider how to look at the operating system from the system view. The first thing I would like to mention is the resource allocator. So since there are a lot of programs running in the computer, and also there are a lot of hardware which are needed by those programs. So the operating system needed to correctly and appropriately assign different resources to different programs to make sure each program can run efficiently without any interruption to each other. So one good example is the network resources. So in your computer, you may use one internet connection to connect the internet. So either by Ethernet or wireless connection through the Wi-Fi or through 4G LTE. And almost all the applications running in your computer require the internet connection. So for example, you may do the web browsing to watch a video. And also the email application is running on the background to check the potential email. So all these programs require the internet services. So how to assign the internet resources to those programs? Because each time the internet resource can only serve one program. So the duty of operating system is to schedule which one can be served first and which one will be coming after to make sure the user experience to be the best. So for example, when you play a PC game and also the email program is doing the checking, so surely you hope the email checking will not interrupt your gaming experience, right? So for those kind of detailed things, the operating system need to take care of them. And the last thing from system view is to serve as a control program. So even for personal computers, there may be multiple accounts on your computer. So for example, the admin account and the guest account. So surely you don't want the guest user can access the admin's files for security purpose, right? And also you don't want to mistakenly delete some system files to crash the entire system. So for all these kind of things, the operating system can help you avoid these misbehaviors to protect your privacy from other users. And also, so when you create your own programs, so when you do the debugging, you may find some bugs there, right? For example, divide by zero or infinite loop or some other mistake operations. So surely you don't want those kind of things to happen. So you hope the operating system can help you handle these situations. Here, it is just a brief summary about what the operating system can do from different perspectives.